Right, yeah, welcome back in our today's class. My name is Victor Digoma here, and in our class today we are going to be looking at one important theorem. Remember, before now we have in our previous classes been looking at different theorems, circle theorems, and we have looked at the theorem that angle at the center of the circle is twice angle at the circumference, the theorem that angle in a semicircle is 90 degrees, angles in the same segments are equal, and opposite angles of a cyclic quadrilateral are supplementary. So all these theorems you have been able to look at them, and I'm trusting God that if you check out on those theorems, you understand them even before this current theorem we want to look at. Now, this theorem we want to look at right now is very, very important. And I am believing that if you follow me, it's a little bit not to make you to become afraid, but I'm telling you that this theorem is very, very important, and I have adopted a very simple way to explain it so that it is not going to, the difficulty in understanding it is not going to be there. So if you look at this theorem says that angle between a tangent and a chord is equal to the angle in the alternate segment. The angle between a tangent and a chord is equal to the angle in the alternate segment. The simple way to explain this, which we are looking at here, is if you have this, something like this, I'm going to show you this, and at the same time, I'm also going to clean it. The simple way to show this is that, assuming this is a circle, okay, assuming this is a circle, and you have a line. Of course, a tangent is of course a line that touches a point on the circumference of the circle, just touches the edge of that circumference. So if you have a chord, all these terms we are using here, I'm trusting God that if you look at the previous classes we've had, you'll be able to capture them. So if you look at this now, and this is something like A, and this is B. Of course, this is a chord because it doesn't pass through the center of the circle. So, and this is a tangent. I can call this, let's say, MN. So this is a tangent. So what we are trying to say here is that the angle between this tangent and this chord, that is this angle here. Of course, if you look carefully, you realize that this chord divides this circle into two segments. So this angle here is this side, this segment is alternate to this angle here. So any angle that is formed within this alternate segment, we are trying to say that this angle here, assuming I label here to be M, okay, and here to be N, what we are trying to explain here is that this angle M, which is in the alternate segment, this is a segment, this is a segment, okay, and there is a tangent and there is a chord. So this angle in this alternate segment is equal to the angle between this tangent and this chord. That's what we're trying to. So M is equals to N. This angle. That is what we are trying to, explain in this theorem. And I am believing God that if you follow me, you see how simple it is to show this theorem. All right. So let me quickly remove this, and then I go back to what we are trying to, show. Okay, back to what we have here. We say MTN is a tangent to the circle at T. Look at M, okay, TN is a tangent to this circle at where? At that point T. Okay, now the chord TR, this chord TR, the chord TR divides the circle into segments. It divides this circle. This is a segment. This is a segment. Okay, into segments TPR. TPR. This is a segment, and this is a small segment, minor segment, and TSR. TSR. So you can see this segment divided by this chord, You can see a small segment here, and you can see a big segment. Okay. All right. Now, where are we heading to now? TPR is alternate to, you see, as I explained, this TPR, this angle here, that is A3, is alternate to NTR, that is NTR, that is this angle A1. Okay, now the theorem we want to show, or what we want to explain, or what we want to prove is this statement that says, show that NTR, this angle NTR, that is this angle A1, is equals to the angle TPR, TPR, that is this angle A3. We want to show that these two angles are equal. Okay, now please pay attention and follow me. I'm not going to rush it. I'm going to follow it gradually. Of course, you will understand it. Okay, look at the way I'm going to go about this. I will say, let me take it step by step. Construction. Okay, I will say, draw a diameter. Draw a diameter. Okay, draw a diameter TQ. Okay, let me do it as I say I do. This diameter, I want this diameter. You know what is the diameter now? It's a line that divides the circle into two, and it has to pass through the center of the circle. So let me draw this diameter. Okay, did you see that from here? Okay, so it passed through the center of the circle, and then I will call that place TQ. This is Q. Then draw the diameter TQ. Then join QR. Join QR. Okay, join QR. I will join QR. I will join QR. Now, there are some things that have been put in place now, which might possibly help us here. Let me call here A2, right? And let me label here, this angle here. Let me label it Y. Okay? So, now, let's move. Let's move. Having done this now, I will now say, consider triangle QRT. Consider triangle QRT. Okay, in that triangle, you will realize something. Do you realize that we have a line here, from here coming down to this tangent? We have a line passing through the center of the circle. It touches, of course, here is the circumference, but it's also touching. Now, there is a theorem that says a line drawn from the center of the circle perpendicular to a tangent is at right angle to it, meaning it is 90 degrees. Let me take it again for the purpose of comprehension. In this triangle now, of course, this is a diameter. Okay, now this line from here, I'm talking about from this center of the circle now to this tangent. Okay, it's a radius, right? It's a radius. Okay, now the theorem of radius and tangent says that a line drawn from the center of the circle to a tangent is perpendicular to it and is also at right angle to it, meaning it is 90 degrees. Okay, so it then means that this angle from this center of the circle here and this T and this N is 90 degrees, meaning that this Y plus this A1 is 90 degrees. We'll start from there. Please, these theorems are important because you have to borrow them to explain this. Of course, if you check in the previous classes we have looked at, we have gone through, you'll be able to capture these things, but just have it like that. Okay, for now. So, if we consider this triangle, we will see that, let me take it over here, that Y, we'll see that Y plus A1 here is equals to 90 degrees. Then I can back it up by that theorem I have just mentioned now. Angle between BW between a radius and a tangent a tangent a tangent okay is 90 degrees is 90 degrees. Okay, in as much as I'm trying to make sure that we don't waste too much time, I'm also trying to make sure that you understand what I'm trying to do here. So can I call this star 1, this equation, can I call it star 1? I can call this star 1. So also in this triangle, still in this triangle QRT, you also see in this triangle here that QRT is 90 degrees. So also here, also in triangle QRT, that QRT is 90 degrees. How? Look at it. QRT, this angle here, let me mark it, that this is 90 degrees. Where is the argument coming from? Angle in a semicircle. Yes, you see that this is a diameter. Please, I did this proof. I did it in just few classes behind. Okay, that angle in a semicircle is 90 degrees. It was well explained. You can look at it. Okay. So having seen that this is 90 degrees, we say angle in a semicircle is 90 degrees. Wow. So can we move on again? Can we advance a little bit? Now, if here we are still considering triangle QRT, I hope you're there. Now, if here is 90 degrees, you know that sum of angles in a triangle is what? It's 180 degrees. It's 180 degrees. I will not go into detail in that. Sum of angles in a triangle is 180 degrees. It then means if I remove this 90, what is left? What is left is 90 degrees, because 90 plus 90 will give you 180 degrees. So if I remove this, it then means that here and here is sharing the remaining 90 degrees. I'm sure that is very, very smooth. All right. So having said that this is 90 degrees, I can say, still in that triangle QRT, that Y plus A2 is equals to 90 degrees. Okay, it's equals to 90 degrees. I would say since A2 plus Y plus 90 is equals to 180 degrees, you say sum angles in a triangle, sum of angles in a triangle. So this holds. I can call this star 2. Wow. So let's move on. I say comparing star 1, that is equation 1 star 1 and star 2, comparing equation 1 and 2, sort of, you will see I have from here that y plus a1 is equals to 90 degrees, and from here I have y plus a2 is equals to 90 degrees. Wow, we have two equations, 1 and 2. Okay, and they have some things in common here, which if you feel like, okay, this is simultaneous, they are simultaneous, we can solve it simultaneously. Okay, so because they have some things in common here, so I can say subtract 1 and 2, subtract subtract them, okay. If I subtract them, y minus y will be 0. Here I have a1 minus a2, you see that, then equals to 90 minus 90, which is what? 0. Now, can you see from here that a1 is equals to, over there, a2? Wow! a1 is equals to a2. Can we see that? It then means that this angle here is equals to this angle here. That's not the conclusion yet, because what we're trying to say is that NTR, this angle A1 is equals to TPR, that is A3. Okay, right. Now, but did you realize that this A1, which is equals to A2, realize that A1, which is equals to A2, that this A2 is also equals to A3. How? How is A2 equals to A3? Wow. Do you realize in the last class as well, I have been able to show that angles in the same segments are equal. Look at it. That these are angles in the same segment, considering the TR as a chord. Angles in the same segments are equal. It has been proved previously. So it then means that A2 is equal to A3. And what is A2? Okay, what is this A3? Look at A2 there and look at A3. So I can now clean this one. I can bring in A1 here and say that A1 is equals to A3 since this. Okay, so that theorem, let me also back it up here. Angles in same segments. Okay, please, you can attach that. So now what is A1? A1 is NTR. NTR. You can see that there. NTR, that angle, NTR, equals to, what is A3? A3 is TPR. TPR. Whoa! This is wonderful. So we have been able to show that A1 is equals to A3. I'm sure that you followed that. That's good. I'm sure you followed that. So the explanation is very detailed. It's very detailed. Very detailed. Now, we have been able to show that angle between a tangent and a chord is equal to the angle in the alternate segments. Angle between a tangent, this A1, between a tangent, look at it, this angle here is lying between this tangent and this chord. I use color to separate. Look at, you can see the tangent RT and the chord, this chord. This angle A1 is lying here. That is equal to the angle in the alternate segment. From that chord, you can see from that chord, okay, from that chord, okay, there is an angle in the alternate segment that they are equal. They are equal. Now, I'm going to take it a little bit further. Please, exercise patience. This is knowledge we are researching here. Do you also follow? Will you also follow if I say that if I say that MTR, that is this angle here. Let me mark it. This angle here, here, this angle here, okay? This MTR, this angle line here, that plus, that it is equals to 180 minus A1, okay? Would you also see that? That also that MT, this angle MTR is equals to 180 degrees minus, I'm trying to manage this space, is equals to 180 minus A1, because they are angle on a straight line. This plus this will give 180 degrees. So this will be 180 minus this. Okay, so you can back it up there. I'm sure you have taken note of this. So I can make a writing here. Bracket angles on a straight line. Okay, angles on a straight line. Now, do you also realize that this same MCR will be equals to, because since you have shown that where is it again, that A1 is equals to A3, okay, that this MTR will be equals to 180 degrees minus A3, okay, minus A3. So A1 is equals to A3. So whether I'm removing A1 or I'm removing A3, they are still the same thing. Okay, so now what is this should be 180 minus A3. So what is this 180 minus A3? Follow me. Let me use this to show it. Let's come here and see something. Let me show you that here. Then I will take you there. Look at this. Look at this. Look at this. Look at this. Then P, R, S, and T. Now, if this is inscribed in a circle, what do we call it? We call it a cyclic quadrilateral. I think I have proved that in one of the classes, that opposite angles of a cyclic quadrilateral are what? Supplementary. They add up to 180 degrees. So if here is A3, here will be 180 minus A3 here, because both of them we have to sum this angle P plus this angle S will be 180 degrees. So if this is A3, this one will be 180 minus A3. So that is what we are trying to bring up here again. Okay, so quickly you accept, you take it that here will be 180 minus A3. 180 minus A3. Here, look at them. Opposite angles of a cyclic quadrilateral are supplementary if you consider this, and this. Okay, so if you consider that, so it then means that, now what is that 180 minus A3? That is that MCR is equals to TSR. TS what? TSR. Okay, so what have we been able to achieve? That the angle between this tangent and this chord is equal to the angle in the alternate segment. Another supporting proof of this. All right, so I'm trusting God that this this and this little attachment to it will be able to help one to understand how to do this proof, that the angle between a tangent and a chord is equal to the angle in the alternate segment. we have been able to show it clearly. And I don't know, I don't know, but I am believing that the detailed explanation I gave here will be able to help one to understand the theorem that says that the angle between a tangent and a chord is equal to the angle in the alternate segment. So please, I believe that what we did here was so helpful to you. And what you can do in return is to like the video, share it to someone, and then subscribe to the channel, because the reason is this: those classes down there we have, you need to check on them, and when you subscribe, you'll be able to have access to all over hundreds of classes you had already. And as well, if you click on the subscription button, you'll be able to be notified, because after now I'm going to be solving practical questions that has to do with these theorems. I've done around 5 theorems already. So these theorems, I'm going to be solving problems that has to do with them. Please, thank you so much for being there.